Hi, this is Sportster Paul. In our engineering disaster series, we're going to talk about why old Fords jump out of park, maybe into reverse, roll in the vehicle if the engine's running, big disaster. Here's two pictures of the big heavy parking pall that's in the back of the transmission that drops in, and you're saying, how can that go wrong? And it's like there's a whole bunch of ways it can go wrong. We'll go over them in this series, in this video here. Here's a press release by the Center for Auto Safety. This was back in 1980, and I'll put links to this stuff, and I have an article that I've written that has links to it. I'll post in the description. The NHTSA, National Highway Traffic Safety Administration, by 1980, they had received 23,000 complaints about Fords jumping out of park and moving, 6,000 accidents, which meant the engine was running or it was on a hill, 1,710 injuries. That's getting serious. And get this, 98 fatalities. So this is a real heavy problem, all right? Now, typical lame kind of partner regulation where, they're almost on the same side, rather than make Ford get all of these trucks and cars back and figure out what was wrong with them and maybe teach them how to design a good system, what the Highway Traffic Safety Administration allowed them to do is send out this little label that you're supposed to stick on your dash or your steering wheel or someplace to remind you to never leave the vehicle in park alone, always use the emergency brake, never walk out. And that's good advice in general. It's not good to leave an engine running with nobody in the car, especially if you got little kids that pull on a lever and then you're in real trouble, right? So let's go over all these reasons and how it happened and all the different things that stack up to make this a persistent problem, all right? The first problem starts right at the steering column where the shift lever is for the automatic transmission. This is a picture of the column with the top part of the column taken off. And you can see up at the top there's this little, I call it an indent plate or a shift plate, whatever you want to call it. And the one narrow slot, that's where it drops into park. And then when you pull it forward, you pull it back towards you and then move it, then it can go in the wide part of the sector and you can shift all the gears, drive, reverse, neutral, all of that business, okay? So here's another picture. Here's an aftermarket, brand new one of them. You can see it's nice and crisp and new, okay? And then here's another picture of an OEM one. See, it's a little bit different, looks a little thinner actually, or a little weaker. And one of the problems, especially if you park your car on a hill, you ever had this happen? And you turn off the car, you put it in park, you let off the brake, and the car rolls forward, goes thunk, or rolls back and goes thunk. Then when you get in the car afterwards, you really got to pull that lever back. Well, that's wearing this plate. And if you wear the plate enough, that web goes between the drop-in for park and the rest of the sector, and now the lever will just flop down into reverse, and if the engine's running, you're in big trouble, or if you're on a hill. Now, here's the other aspect, the opposite side of this, is the lever itself. Here's a picture of what's on the end of the shift lever on the steering column. It's got this little protrusion, right? This little boss has to stick out, and that's what drops in the slot or drops in that longer hole. And this can wear out, right? And I see guys on forums, well, I filed it and got it. That's really sketchy, right? But it's hard to find parts for these older, 1980 and before vehicles. So that can be a headache. So be careful when you're repairing this, but the first place you might have a problem is up here in the steering column, all right? Right? Tell me a story. Okay, I will. When I worked at Ford back in 1980, this might be an urban legend, but one of the powertrain guys told me that little plate that goes on the steering column, there was a truck version and a car version. And they were color-coded. The vendor would paint them different for the different ones so you could easily tell which was which. And those going into the column. And there was a plant, Louisville plant, that built both cars and trucks. And naturally, because they weren't color-coded, they got swapped. And I think the car plate in the truck is what caused the problem. And it wasn't a big deal. Like I say, this might be an urban legend, but with that plate not being wrong, well, you didn't get enough travel and you didn't put it all the way into park. This was only a few hundred vehicles, supposedly, but classic disaster, because you can imagine to fix it, you got to either take the column apart and put the right plate in or replace the whole column, right? You got to make it right. You can't fix it elsewhere in the system. So that's a fun story. Not sure if it's true. Okay, from the top of the steering column, let's go to the complete opposite. Let's go all the way through and look where it ends up at the back of the transmission at the parking pawl assembly. So here's a little diagram, and it shows that parking pawl in red. And when it's back, fine. It is out of the way. There's a spring that actually holds it back, so it's not hitting that segmented wheel. Then the other half of this is when you drop it down, it drops into those slots in the wheel, and the way it's cut, pressure forward, pressure back, neither wants to pop that little pawl out of the wheel. So that's, rock solid, good stuff. Now, here is a picture, same one we started with. Here's a picture of the parking pawl for one Ford transmission. You can see this one is, I think I started with it in. Yeah, this one's in. Here's another picture. Here's where the parking pawl is retracted. And this is big, heavy, beefy, steel, metal, iron stuff. And you're like, how can this go wrong? Well, if the vehicle's rolling pretty fast and you slam it into park and that thing accidentally, it hits it perfect, it doesn't start bouncing, making that horrible noise. If it actually drops in, you can break that metal pawl, right? You'll break it in half. You'll kind of know you did that. And I'm not sure if you have to pull the tranny. You might be able just to take the tail shaft off, get in there and fix what you have to fix. But this is pretty rock solid, right? Everything's so precise, everything's machined, it's pretty dependable and repeatable and manufacturable, right? So this isn't the problem, okay? All right, the problem is that what they don't show in that little diagram, the first one I showed last segment, it doesn't show what happens if that pawl drops and it doesn't just happen to hit a groove, right? What if it drops on the outside of the wheel? You can't have a direct connection to the lever up on the column because, it would jam up and something's got to give. So what you do is you purposely put compliance, some spring-loaded gizmo mechanism that takes pressure and puts pressure on that pawl on the top of the outside of the wheel so that when the vehicle does roll forward a little or roll back a little, a groove comes up, it'll drop in, right? And that has to be designed in. This is pretty precise, but here's a picture of an exploded view of the whole transmission, generic Ford transmission. That red ellipse shows where there's a thin little rod. See, the operating lever for the transmission goes in right about the middle, because that's close to the valve body. And that's what that lever's doing, is switching valves in the valve body to make it forward, reverse, first gear, second gear, stuff like that. So then to get back to that pawl in the back by the tail shaft, they run this narrow little rod back, and that can cause a problem. Now you're starting to get into manufacturing tolerances, or somebody dropped the transmission, dented the pan, bent the rod. Now the rod's a little shorter, right? It's not going to really go as far as it's supposed to. Let's shoot another picture up here. Okay, this picture is an exploded view of just the mechanism. And I wish I tried to find places that would explain exactly how this compliance worked. But you can see there's that big wound up spring on a stud, and that winds up. And so when the rod goes forward, because that's hard attached to your linkage, so when that little rod goes back, it trips all this little mechanism to start making the pawl slap down. If it's on the outside edge, it stops, but with a lot of pressure trying to push it all the way in. So things can go wrong there. One of the problems is that little rod, you see it has bends in it. Well, that makes it much harder in production, high volume production, to control the length, because you're putting bends in. Did you bend it exactly the same? It's kind of an uncontrolled operation. Metal always springs back a little from the initial bend. So then you can make a fixture and kind of have a go, no go, but that's all added cost. It would have been much better if they just had a fixed straight rod. So that's one issue I see. I don't know why they just didn't do it like Chevy, and I said that to one of the powertrain engineers. They said, oh, well, that'd be admitting we have a problem. I said, well, you do have a problem. Fix it, right? No shame in that. No shame in copying what works, but this is only part of the problem, right? And actually pretty minor, I think. Problems inside the tranny, pretty rare, because they're built one way and they're supposed to work, okay? So let's look at another very contributing factor to this problem, and that's in the linkage that goes from the end of the steering column to the little lever on the transmission. Let's shoot this up. So this exploded view, it's really complex, because one of the problems you have is the transmission is kind of moving. It's on motor mounts and it's hopping around a little. Column is fixed to the cab, but the cab's on rubber mounts to the frame, so everything's kind of moving a little. So you'll see like little Pitman links and stuff where it's trying to transfer, it's trying to decouple any motion between the two items, between the tranny and the cab, so that the column is where it's supposed to be. You know, the linkage goes right. But you'll also notice, let's throw up another picture. Okay, here's one version of that. This is just a zoom in of that previous one. Okay, and then here's another picture, a zoom in. And you can see there's multiple ways. So this is some of the horror of different engines, different transmissions, different engines, 4x4, all the different, you know, truck, Bronco, whatever, all a little different. So now you've got two problems, or three. One, you could put the wrong parts in at the factory, right? Or the guy building some engine swap, puts the wrong parts in. And now the motion isn't right, and you're not putting it all the way into park, and that lets it pop out. Next, you've got manufacturing tolerances, more bent rods where you can't quite control the length and things going different. And then finally, you have a wear-out mechanism. As those bushings, all the pivot points, wear out and get sloppy. Now, you think it's all the way in park, but it really isn't. So the linkage is a big part of this, and how it's made, if it's the right parts, all this other stuff. So that's another reason why they pop out of park into reverse. Okay, let's go back up to the column. Here's a picture of a used column I found. And you look at it and you think, well, okay, if that little plate and the end of the shift lever is okay, you know, that rotates a tube, and as that tube turns, it rotates that lever at the bottom. You can see it close down here at the bottom of that picture. You say, well, you can't get into too much trouble there, but you can. And this is where design engineering can go wrong. Notice that lever has two bends in it to move it down. Those bends, same deal with that little rod inside the transmission. That's an uncontrolled operation. You're not sure how thick's the steel, how much is it going to spring back. You know, it would have been much better if they could figure out a way just to make a straight steel link where this hole and this hole, you can make that to the thousandth of an inch, 2 or 3 thousandths of an inch in a stamping press when it comes down on just a flat bar of steel, right? And then you don't bend it, you don't mess with it, you just weld it to the tube and you weld it, or you don't weld it, you put the bushing in the other end. And that would have been a better way to make the column. Just out of curiosity, if you're wondering, here's another picture. There's a reverse switch, so that when you go into reverse, it senses that and turns on the backup lights, okay? Thought you'd be interested in that. And so here I found, as I did all the research for this article, here's a 1957 Ford truck. And now that sector plate that ended up in the column, this tiny little delicate thing, it was down at the base of the column where you could see it, but where it's in the engine compartment, it gets dirty, gets grimy, you know, and wears out. And so here's a guy who cleaned his off and took a picture for the rest of us to help us learn. This is where it wears down there, and the same problem. If you lose that function, it'll fall into gear. So it's been a problem for a long time. And can you blame Ford when stuff wears out after 20, 30, 50 years of use? Well, not really, but there are more robust and less robust ways to design things. So why do old Fords pop out of the park? Well, a lot of reasons, right? It's a combination of things. It could be stuff inside the transmission is bent or not lined up. In general, it's that the lever on the transmission isn't getting driven all the way. That can be stuff worn out. That can be the wrong, well, probably not the wrong lever on the tranny, but maybe the wrong rods for different models, and also something wrong at the column, right, where that sector insert plate wears out. So a whole bunch of different things can all combine to let that Ford pop out of gear. It's not it's a constant problem. I found a 2017 recall of Ford trucks where they pop into gear. And I didn't look into what that was, but trying to relate a lever, getting it across something that vibrates. Back in the day when I worked at Ford, I said, well, why don't we put in a cable? Young and dumb, one of the powertrain guys says, well, think about this now. Cables can only pull, right? You can't push on a cable. So what you'd have to do is put this huge spring down at the transmission and then pull the thing. If the cable breaks, the spring would snap it either into park or into low. Either way is a disaster, right? So now you got to run two cables, a pull cable and a push cable. A pull cable to go one way and another pull cable to move the arm the other way. So now, a steel rod is dirt cheap. Ford, cheap back in the day. finance guys ruined that company back in the 80s. So they're not going to go something more expensive, and cables can be troublesome. It does perfectly decouple the movement of the engine with the movement of the cab. Interesting side story, I owned a 69 Impala that when the motor mount broke, the engine would whack over and it would put the thing full throttle. So that was fun. The first, I think it was a left turn I made coming out of a driveway, and it went full throttle, and it's like, what's going on? So cables get you out of those kind of problems. But he said, cost. Steel cable, a hardened steel wire, and then you wrap it once, and then you got to keep it lubricated. So putting a cable in at that time, I think they use them in other cars now, but at that time, that wasn't going to fly because of cost. Now, the final thing I want to leave you folks with, what if you're doing an engine swap? What if you're doing something different? What if you're just restoring an old car? You've got to be the engineer then, right? And my recommendation, would be go to the lever on the transmission as installed. Get a big channel lock or something, go all the way, park, mark it, how far it went. Go all the way back in the other direction, right? Which would be, I guess, low 1. Mark it so you know what the full travel of the lever on the transmission is going to be. Then go up and, try to make sure that little sector plate's good, make sure things are nice and tight, look for all the loose bushings, look to see, and then just relate the motion of that steering column lever with how far it's moving the lever, and is it going to move the lever all the way, right? If that lever doesn't, you shouldn't have to bind it in, right? I mean, it should be free. There's so much stuff on a Harley that works like this, right? The throttle cable. You don't want the carburetor to stop the throttle cable. That'll eventually break the cable. You want the stop up in the throttle to be just perfect so that when the grip stops against that stop, the cable doesn't have hardly any tension. It's not pulling hard against the stop in the carburetor. It's that same kind of principle, just perfect. And so, you probably need a hoist, get up there, check all this out, and make sure you have the right parts. If you're doing something weird like an engine tranny combination that's never been in there before, now you've got some real engineering to do. And you may have to change or lengthen levers, to get the right amount of motion. You may have to straighten out that bent lever so it goes further. But in general, make sure you're getting the full motion and make it line up. And then you got the final problem, which we always worried about in the auto business, the prindle. That little thing on top of the column, park, reverse, is called a prindle, slang. That has to line up with all the rest of the stuff. And that, little cables, that was another fun thing to make that needle work right. But good luck if you're building something like this. It's a lot harder than it sounds. As you can tell, when Ford has problems like this billion-dollar multinational, be careful when you build something, all right? Sports to Paul, hope you had fun. Catch you next time.